In the previous video, you had seen about midpoint theorem. There, the information given was that we were provided with the midpoints of two sides of a triangle, and when we had drawn a line joining those two midpoints, we had got a line which was parallel to the third side, and its measurement was half of that third side. Now we will be seeing the converse of that. So let us see first the statement based on that. It says the line drawn through the midpoint of one side of a triangle and parallel to another side, then it bisects the third side. So information given is midpoint of one side and a line is drawn parallel to another side. Now the third side where the line will go and meet, it will be the midpoint of that third side. So let us take a look at it by the help of this figure. In this triangle ABC, we are given here D as the midpoint of AB, so I mark these two equal, and then this line DE is parallel to BC, I have marked it. So now this line DE, where it meets AC, it is bisecting it. So we will be getting AE equals to EC. A short way of representing this theorem goes like this. If D is the midpoint and DE is parallel to BC, then we get AE equals to EC. Now how will you come to know that in a sum requires the use of this theorem? Just look for two things, a midpoint provided and the line from that midpoint is parallel to a side. And now wherever it goes and meet the third side, you take that point to be as the midpoint of that side. Prove this converse midpoint theorem. So first of all, let us write this given part. So in the given part, the question provides us that is in triangle ABC, D is a midpoint and this line D is parallel to BC. And then what we have to prove is here that AE equals to EC. So these two parts we have to prove it as equal. We need a construction here. That construction is that from this point C, we have drawn a line CF which is parallel to this line AB, or you can say BD. And then we have produced this DE to meet this line CF at F. So draw CF parallel to BD and produce DE to meet at F. Now the proving part. Now first of all, you can see here we were already given that these two lines are parallel. In construction we have drawn these two lines as parallel. So both pair of opposite sides are parallel. So I get BDFC is a parallelogram, and written the reason both pair of opposite sides are parallel here. Now if it is a parallelogram, I will be getting this BD and CF as equal. So written here BD and CF as equal, reason being opposite sides of a parallelogram. But we were also provided that this BD was equals to AD. So written here BD equals to AD, written as equation 2, and we were given that. Now if you take a look, BD is equal to CF, BD is equals to AD, it means these two have to be equal. So I have written AD equals to CF from equation 1 and 2. Now I will be taking these two triangles, okay, these two triangles, and prove them congruent. So I have written here in triangle AED and CEF. So first of all, I am getting these two vertically opposite angles as equal. Okay, angle AED equals to angle CEF as equal, and then I get this angle DAE is equals to angle ECF by alternate angles. Okay, and then we had already proved that AD and CF are equal here, so written the reason they proved above. So we have got the two triangles congruent by the rule angle side. And so once the two triangles are congruent, these two are congruent, I will get AE equals to EC, AE equals to EC by CPCT. So the sum has been proved quite easily.